Let's take a look at Gabriel's horn. Gabriel's horn is formed by rotating the function f of x equals 1 over x from 1 to infinity about the x-axis. Let's find the volume. To find the volume, we will use the disk method. This will be the radius of the corresponding disk, and the area of a disk is pi times the radius squared. The radius in this case is the function, so we will have pi times 1 over x squared. Therefore, the volume will be the integral from 1 to infinity of pi times 1 over x squared. We'll factor the pi out to the front. We'll introduce the limit symbol since this is an improper integral. We'll go from 1 to b and let b go to infinity. X to the minus 2 dx. This will give us pi times the limit x to the minus 1 over minus 1, which is negative 1 over x. From 1 to b, this is equal to pi times the limit of negative 1 over b plus 1 as b goes to infinity. This is equal to pi. So therefore, Gabriel's horn has finite volume, and that volume is pi, units cubed. Now let's go ahead and find the surface area. So for surface area, we're going to use the formula integral 2 pi r, that's the circumference, with respect to s, and we'll go from 1 to infinity. Okay. In this case, we will find ds by looking at the derivative of 1 over x. So ds is going to be the square root of 1 plus, let's come over here for a moment. If y is equal to 1 over x, y prime is equal to minus 1 over x squared. So this tells us that ds is going to equal 1. On the inside of the square root, we'll have 1 plus 1 over x to the 4th when we square the derivative. And then that's all multiplied by dx. So let's go ahead and substitute this in. So we will have surface area is equal to 2 pi integral 0 to infinity of the radius, which is the function, times ds. Let's get a common denominator of x to the 4th inside this square root so that we can write ds like that. We can simplify this a little bit, and let's go ahead and introduce the limit symbol. Well, the limit as b goes to infinity. And I see a typo over here. This should be 1 to infinity. So 1 to infinity. Oops, now that should be 1 to b. Okay. In the numerator, we have the square root of x to the 4th plus 1. In the denominator, we're going to have the square root of x to the 4th, which is x squared, multiplied by x, giving x cubed. All right, now we have to be a little clever here. That integral is not easily evaluated, but what we can do is say this. We can say that that integral is going to be very closely related to the following integral. In fact, it is going to be greater than the following integral. If we replace in the numerator x squared, x to the 4th plus 1, if we replace that with just x to the 4th, we will have that. Everybody agree? If we decrease the numerator, we decrease the fraction value. Let's keep on trucking. And this, technically, this will be equal to what I'm about to write. Just keep in mind that we have this inequality symbol over here. So this part will be equal to 2 pi limit 1 to b, x squared over x cubed is 1 over x dx. That should look familiar to us. That is in turn equal to 2 pi times the limit of the natural log of x from 1 to b. And what we will see here is that we have divergence. Natural log of b minus natural log of 1. So this will all equal 2 pi times the limit as b goes to infinity of natural log of b. And that is infinite. So therefore, there is infinite surface area. Because we have the inequality above that the actual surface area is greater than the value of this quantity right here. And we just showed that the value of that quantity is infinite. Therefore, the surface area must also be infinite. Kaboom.